Now, this inequality here means that x is greater than or uh, equal to 1 and x is less than or equal to 4. So we can put this as one statement and say this means x is greater than or equal to 1. Um, Now, I'll try to explain this. Um, so what I'm going to do here is to try and split this inequality. This is a double inequality. Some people call it compound inequality. So I'll try to split it so that you can understand why I'm trying to describe it the way I'm describing it. So I'll split it into two. So this part here separately, and I will split this part here separately. Now, this top part here, I'll end up with this inequality, and that's basically what I have here as my first statement. uh, X is greater than, sorry, uh, that is what I have as my second statement, less than or equal to 4, right? So now on the left, I have this inequality, this one here. Now, what I can do here is I'm going to swap sides and change the direction of inequality. Remember, if I have something like 3 is greater than 2, well, if I swap the sides, if I swap these sides, I'll end up with 2 is greater than 3, which doesn't make sense. So what I have to do here is when I swap the sides, and this applies to all inequalities. When you swap the sides, you have to change the direction of the inequality. So I have to change it to that. So that makes sense because now uh, initially we had 3 is greater than 2. When I swap the sides, I also change the direction of the inequality to end up with 2 is less than 3, which makes sense. So what I'm implying here is I'm going to do the same thing here. So if I swap this, I'll use a green pen here just to demonstrate that. So if I swap this, swap and change, so swap sides, and change direction of inequality. So when I swap those sides and change the direction of an inequality, I'll end up with x is greater than or equal to 1. And this makes sense because if you look at this statement, remember what I said in the initially. I said x is greater than or equal to 1, which is here. X is greater than or equal to 1. And the other statement is um, x is less than or equal to 4, x is less than or equal to 4. We put this together by using this word and, which is very important. So x is greater than or equal to 1 and less than or equal to 4 means that all the values of x that are required here have to be between these two values. And remember, these two values are inclusive. So basically what you're saying here is uh, x can be 1, Yeah. Or it can be 4, or x can be any number between 1 and 4. So how do we represent this in number line? All that you have to do is draw a number line. And if I can start from -1, and let me just partition this way. So -1, 0, 1, 2, 3, 4, 5, 6. So what you're saying here is x can be any number between 1 and 4. But remember, 1 and 4 are inclusive. So what I'm going to do here is at 1, I'll draw a shaded circle or dot. At 4, I'll do the same, and then join these 2 points. So basically what you're saying is x can be any number between 1 and 4, including 1 and 4. Also look at another example. How about if I have x is less than 0 or x is greater than 3? So this means that if you are to pick one value of x, you either have to pick an x on the left side, which means in the range of values where x is less than 0, or x on the right side, the values where x is greater than 3. So what I mean by that is, just write that statement. So if you are to pick just one value of x, you either have to pick an x value on the left side, in x is less than 0, or an x value on the right side in x is greater than 3. And maybe if we represent this on a number line, it will make more sense. So let's just go straight to the number line. So -1, just partition these guys. So 0, 1, 2, 3, 4, 5, 6, 7. So what you're saying here is x is less than 0. That does not include 0. So to the left. Or x is greater than 3. So anything to the right.